Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Tonight, I'll be doing the review for test number 3, which I'll be giving tomorrow, and you'll have until Friday, 8 p.m. to upload your answers. Now, let me just remind you that test number 3 will be online tomorrow, 8 a.m. or earlier, depending on what time I get up. I will send out the password in an email to you and also put it in an announcement for the PDF, password PDF file for test 3. And as I said, you have till Friday, 8 p.m. to hand it in. And just to remember, test 3 has 9 pages, 10 problems. It will cover carboxylic acids, esters, carboxylate anions, amines, amine salts, quaternary ammonium salts were near and dear to my heart because it helped pay for my house and a number of cars, and amides and heterocyclic compounds, which also I worked in. All right, points breakdown, general knowledge, 7 points, nomenclature, 38 points. Remember, nomenclature is give the name, in this case, because of amines and quaternary ammonium salts, also either the IUPAC or the general name for a structure, and also draw the structure from the name, IUPAC or general name. And then 60 points will be reactions. And here, most of them will be give the organic product or products or the following. There'll be a couple synthesis, give the starting material. Now, one other thing I want to point out, if we go to the assignment area of D2L, you'll see, oh, look, the extra credit project, which is optional. Let's take a look at the extra credit project. And you can download this. The extra credit project is worth 10, 5 plus 5, 10 bonus points if you get it right. And what do you have to do? You have to create a chart that contains 10 organic molecules. Remember, this is organic chemistry. Sodium bicarbonate is inorganic, which are found in the ingredients list of products that are commercially available. In other words, stuff you can buy. Now, you can only use a molecule once in the chart, and you can get up to 3 molecules for products. This way, I'm forcing you to look at a number of things, like at least 4. All right. Now, to get full credit, 1 point for that molecule, all entries in a row of the chart must be correct. For each entry, you have to record the name of the product, the name of the molecule that you're using from that product, and one of the functional groups, if there's more than one in that product, or only one, if it's the only functional group that's in that molecule. Be sure to put your name on the chart. I used to have that when they'd hand it in face to face and students wouldn't. All right, here's an example. Say you had brand X wine. It contains ethanol and it's an alcohol. Now, to make this interesting, you can't use the following molecules. You cannot use sucrose, ethanol, isopropyl alcohol, acetone, ethyl acetate, propane, acetic acid, or methane. Any other molecules are free to use it. Now, you can't use the following products: beer, wine, vegetable oil, vinegar, gasoline, propane gas, natural gas, orange juice, milk, sugar, or butter. Anything else is available, any product. Now, note, this is important. Ingredients must appear on an ingredients list on the product, and they must contain a functional group we discussed in the class. Now, there are other functional groups I didn't cover. And through the years, when students put those down, they always get them wrong. So just stick to what we've covered in class, which is a lot. Now, this is due by the end of the day on July 22nd, which would be 11:59 p.m. and no late projects are accepted. Now you can make a table as a PDF file or just do it as a Word file when you upload it. Now, this is important. This is an optional project. You don't have to do it. But if you want 10 points, 5 plus 5, you should do it. Now, your misconception over the years, student thinks they have to have 10 different functional groups. No, if you, from different products and using different molecules, you could have them all double bonds, alcohols, ketones, aldehydes, or any mixture. Now, this is important also. Beware, not all names on labels are IUPAC or common names. They're trade names. An example is simethicone. You said, oh, ONE ending, that's a ketone. No, this is a trade name, and that's a silicone compound, which we didn't touch in this class. Now, how do you find out what functional groups or the molecule? Well, the easiest way is use your favorite search engine. Mine's Google, has been since about a week after they came online in I think it was 95 or 96. A friend of mine from California called me up and said, you got internet access. And at that time, they limited it at companies. I was one of the few in my company who did have it. Said, go to this place called Google. I said, what's a goggle? No, it's Google. And I opened up and I see this little box. What am I supposed to do now? Type in a question or something. Wow, is this cool? And it has been. All right, so you can put in there to use Google. Also, you can ask me if you need help by email or come to my office hour. To use Google, place the name of the chemical, and then type in the phrase afterward chemical structure. When the first 3 hits will show you the structure. Now, as a special service, well, first of all, let's give an example of how to get 1 point. How many of you are familiar with this product, Carmex? You know, in the winter, you put it on your lips, makes it tingle and keep them from drying out and cracking. I've been using this for a long, long time. And if you look at the label, you'll see it's got a number of chemicals, and one of them is phenol. And phenol has 2 different functional groups, but you only have to pick one. So you could put product, Carmex, molecule, phenol, and functional group, alcohol. And you got 1 point, and you just need 9 others. Now, if you look at the label here, there are 2 more than 2, but you can only get 3 from a product. There are 2 more you can get from here. So if you have Carmex at home, or if you want, go to your local drugstore or supermarket and write down, or take your cell phone and take pictures of the labels and do that at home. And that's, you can use this. Anybody watching the video now or here live, you can put down Carmex, phenol, alcohol, or you could have also put down benzene or aromatic. All right, now as a special, or what I call service to my students, you email me your chart before you submit it in D2L. I will check it. If there's anything wrong, I'll let you know what you got to fix. So there's no reason everybody shouldn't be able to get 10, yes, 10 points. All right, time to go on to the review. And if you look in the lecture section of D2L, I don't know if you have to scroll down at the bottom and click on the button more, you will see a file cleverly named Test 3 Review. And let's go through it. All right, first of all, this is a carboxylic acid. Carbonyl, OH group, R group. How do you name it? You find the longest chain with R and the carbonyl carbon, name it as an alkane. Drop the E, add OIC in the word acid. Now, when numbering substituents on the R group, the carbonyl carbon is always 1. Carbonyl carbons rock. But anyways, besides that, and you don't have to put that number down. And again, what you're seeing on the screen, you can download from Blackboard. Oh, wrong school, D2L. I'm sorry, I do that all the time. At ECC, the computer system is called, for students and faculty, is called D2L. At COD, where I teach College of DuPage, it's called Blackboard. It's a different one. All right, there are three common names I've asked you to learn the structures of: acetic acid, formic acid, and benzoic acid. And you should know acetic acid and water forms vinegar. So next time you look at a bottle of vinegar, you can say, aha, I know there's acetic acid in there. And all vinegars are acetic acid. And there's some minor other things to make it taste different. My favorite is apple cider vinegar or Moroccan rice wine vinegar. Those are my two favorite. And regular vinegar is nice too. All right, let's look at certain reactions of carboxylic acids. They're called an acid because the hydrogen on the hydroxyl group of the carboxylic acid is acidic. And you can have a proton transfer. You take a carboxylic acid, react it with a base. The base is MOH for this class. There are other ones. And here, M is lithium, sodium, or potassium. And you have an acid-base reaction. And most of these reactions, I ask for just the organic product, not the inorganic. In this case, you get water too, but I don't ask about that. It's inorganic. And you get this carboxylate anion. Now, before I go any further, I was talking to one of your colleagues earlier today, and I closed it, so you'll have to wait for a second, more than a second. If you look at the problem set, you'll see I have a carboxylic acid for 6A, and I have calcium hydroxide. Ignore that. Ignore A and ignore B. 6A and B, ignore, because I didn't talk about calcium hydroxide. At one time years ago, I used to, but I don't anymore, and I didn't change my problems. Wow, I'll be darned. Look at that. The problem sets are 11 years old. Do I recycle good stuff? Of course. So remember 6A and B, and you don't have to know that. All right, now a special base is sodium bicarbonate, and that's baking powder. And this one, if you look at the problem set, for this reaction, I ask give all the products, including inorganic, which is rare. I usually don't, but this one I do. And if you take a carboxylic acid plus baking powder, you get an acid-base reaction. You get the carboxylate anion, the sodium carboxylate, plus water. and carbon dioxide given off as a gas. And I hope you all remember the very special story I shared with you, how my father taught me in this little rocket ship to put in vinegar, which is acetic acid, a carboxylic acid, and baking powder, and the CO2 builds up and the front pops off. And boy, when you're 6 years old and you show your friends that, they think you're the coolest person in the world. And they also thought my father was, which he was. I can still picture decades ago when he showed me that, and I showed my friends. But you should know that. Now, how do you make a carboxylic acid? If you take a primary alcohol and oxidize it, you'll get a carboxylic acid. If you take an aldehyde and oxidize it, you'll also get a carboxylic acid. And then something that makes me happy and one of my favorite areas is a Grignard reagent. And if you take a Grignard reagent and react it with carbon dioxide, see that's CO2, second step acid and water, where X can be chlorine, bromine, or iodine, you get a carboxylic acid that's one carbon longer than the carboxylic acid you start with. And you know something? I should share the fun with you people. So I'm going to help you out tonight. But on tests, this you have to learn for yourself. Here's the general reaction. And the question would be, what's the organic product or product for the following? Your turn. I'm going to let you have some fun. And when you're done, give me a thumbs up, either if you have your camera on or use the emoji, which they should rename that emotional symbol or whatever. I wonder who came up with emoji. Yeah. All right, I think everybody's done. My turn. Sound familiar, like on the videos? All right, what's different? Look at a molecule for what's different, what's not carbon, what's not hydrogen. Should get your attention like this. Oh, I got it in tonight. And we have, a magnesium iodine on carbons. This is a Grignard, where X can be chlorine, bromine, or iodine. I forgot to write it on top, plus CO2, second step acid and water. And you get a carboxylic acid that's one carbon longer than the R group. You're making a carbon-carbon single bond. R plus this carbon is one carbon longer. What's my R group? Do you break carbon-carbon single bonds, everybody? No. So I have three carbons like this, plus my methyl group. Which carbon had the Grignard? The end one, that's the one that's going to be attached to this carbonyl. And there's 4 bonds to carbon, so I can put in my hydrogens at warp speed. And there's you do it. Now, before I move on, I'm going to check. Do you break carbon-carbon single bonds? No. And this one adds 1. So notice I have 3 across plus 1 more is 4. Plus on this carbon here, there's the methyl group. And that's a check you should always do. Remember, your friend on any of my tests are, do you break carbon-carbon single bonds? No. And also, how many bonds to carbon? 4. Well, that was fun. I hope you had fun. All right. Now we'll go on to esters. What is an ester? That's a carbonyl, carbon double bond to oxygen with an R group. That carbonyl has an R group oxygen, and that oxygen is R prime. Remember, R and R prime mean anything with carbons. And we use the prime to say that could be the same as the R group or different, just like in math uses X and Y. Now, nomenclature. For an ester, you name the R group in front as an alkyl group, like methyl, ethyl, T-butyl, and so on. Now, for this part of the ester, pretend R prime is an H and name that as a carboxylic acid. Then you drop the IC in the word acid and add ATE. Now, many years ago, I had a really sharp student. I haven't seen him in a long time. And he came up to me and said, Dr. White, can't we just name the alkane as the longest chain and then add OATE? And I said, except for when R is a benzene ring, you can. So that's why I have 2A and 2B. And if you watch the video, I say, to be or not to be, that's the question. Sorry, I did it again. All right. Now, there's one special common name you should know, and that's ethyl acetate. Nobody calls that ethyl ethanoate, the IUPAC name. That's ethyl acetate. And you should know this is one of the 2 molecules that's in nail polish remover. How many of you are familiar with the nail polish that after you put it on, you put it under the light, UV light to harden it, or in chemistry, we call that cure it? And that's been around for not that long, about 5-10 years. And that puts a much more durable coating on your nails. And ethyl acetate used to be the most dominant one because it smelled better and it felt nicer if you had a little cuticle or cut on your finger, but that wouldn't remove those types of things. So now if you go to the store, most of them are acetone. All right, next, since we're talking about nomenclature of esters, let's talk about nomenclatures of carboxylate anions, where M can be lithium, sodium, or potassium. Name M as the element it comes from, either lithium, sodium, or potassium in front. Then you have the same 2A or 2B as for the ester. The IUPAC way is name, think of that if that was OH instead of O minus M plus, name it as a carboxylic acid, drop the IC in the word acid and add OATE. But if R is not a benzene ring, then you can use B2. And that's name the alkane, including the carbonyl carbon, longest chain, and drop the E and add OATE. Now, as a special gift to you, don't tell anybody I'm being nice. And I said this in the lecture videos on test 3, both for a car ester and a carboxylate anion, there'll be no alkyl groups on the R group, because then the name starts getting very interesting and complex. Now, you should remember esters are responsible for the smell of flowers and the taste and smell of many fruits and vegetables. When I go into the supermarket, when I walk by the bananas, I think, oh, I know that ester. Or if I go for a walk and I smell the flowers, I'm thinking, wow, those esters smell nice. All right. How do you make an ester? Williamson ether synthesis. If you take an carboxylic acid, react it with an alcohol, acid catalyst, H plus is acid catalyst, like sulfuric acid or other acids, but we just an organic. Since there are many different ones you can use, just use H plus, you make an ester. Now, let me remind you, first of all, let me write the general reaction. By the way, sometimes I'll write it like this. Instead of with the H plus there, I'll put it slash H plus. That means the same thing. And you'll get an ester. And I worked for one company that made esters. In fact, I had to do some problem solving when they had it. And the question is, give the organic product or products for the following molecule. And I'll do this one because I want to show you something important. If we look at the first molecule, look for what's different. Ooh, it's a carboxylic acid because I see the carbonyl and OH, and that's a carboxylic acid. Second molecule, ooh, OH on a carbon, alcohol. Acid catalyst, I get an ester. So what's my R group? At methyl. What's my R prime? An isopropyl. And the reason I use this example, the carbon in R prime with the OH group, the carbon with R prime in the OH group is the carbon this oxygen will be bonded to an R prime. I'll say that again. The carbon in R prime with the OH group is the carbon this oxygen, the ester, is bonded to. So I have my R group, methyl, my carbonyl, my oxygen, because that's what this shows me. And then my R group is 3 carbons. Notice the hydroxyl group is on the center carbon. So my center carbon of 3 will be the one you have. Now, first of all, wait, does everybody have this copied down? Don't forget, later tonight, I'll be posting this video or tomorrow morning on my YouTube channel, so you can always come back and watch it. And I think I have 4 synthesis, maybe 5 on test number 3, maybe less, but I have a couple. And the question would be, what 2 things do you react with H plus to make that molecule? While everybody's copying that down, I'm going to have some water. Water break. So how do you do a synthesis problem? You look at the product and say, what functional group do I have? And you look for what's different. Carbonyl, oxygen, R here, R prime. I have an ester. And what do I react with acid catalyst to make an ester? A carboxylic acid plus an alcohol. So what's my R group? What's ever attached to the carbonyl carbon? What's my R prime? What's ever attached to the oxygen here of the ester? So immediately I can write my R group is 2 carbons. I have my carboxylic acid. By the way, this is a fun part of organic chemistry, synthesis, how do you make things? And remember, the R group with the oxygen here will be the R group, the carbon with the OH group, which is the end one of 3. And I can write it this way so you can see it better. Or just like, here's my left hand. Ooh, something different. No, it's still your left hand. You rotated it. Molecules rotate in 3 dimensions, which we all live in. And you could have written it this way. Both of those are 1 propanol. And that's how you do a synthesis problem. Now, what are reactions of esters? If you take an ester, react it with acid and water, you'll get back the carboxylic acid plus the alcohol you would have used to make that ester. And later on, we're going to be talking about this reaction because right now where you're sitting, where can you find acid and water? Wherever you are, each of you, in your stomach. And we'll learn that later in the semester, we get into fats and oils. This is how your stomach breaks down fats and oils to make carboxylic acids, otherwise known as fatty acids, plus the alcohol is glycerin. So anyways, you should know that. Now, if you take an ester and react it with a base, MOH, where M is lithium, sodium, or potassium in water, this is called base hydrolysis or saponification of an ester. And you get back not the carboxylic acid, because in base, the carboxylic acid forms the carboxylate anion. You'll get the carboxylate anion of the carboxylic acid you would have used to make that ester plus the alcohol. And the OH group here is the carbon that this oxygen is bonded to. And finally, one of my favorite, why? Because we're using a Grignard reagent, actually 2 molecules. And I've done this reaction. Almost all the ones I talk about in class I've done. I think only 1 or 2 I haven't. But anyways, if you take an ester, react it with 2 molecules of a Grignard, and I don't have it here, bad Dr. White. X can be chlorine, bromine, iodine. Second step, acid and water. You make 2 products. You make an alcohol where you do something very special, something very rare. You make 1, 2 carbon-carbon single bonds to what was the carbonyl carbon. And this OR from the ester becomes the second alcohol. And it's a way of making a very complex molecule very quickly. Oh, let's do one. I want to have some fun. And let me do this one. And test, normally I'll put a plus there. That's my way of being nice, let you know there are 2 products. And What do we have that's different in this first molecule? It's an ester. Then the first step, magnesium chloride, that's a Grignard, and there are two of them right here. At my level, we don't even put the two there because organic chemists don't like balancing equations, but I will do that. Remember, X can be chlorine, bromine, or iodine, any of those halogens. Second step, acid, H plus, and water. And what do you get? Two alcohols. So let's find out what's this methyl group. What's our prime? This methyl group. What's our triple prime? This isopropyl group. So let's start writing our structures. So I have my R group, methyl. I'll have this carbon. We'll have an OH group on it. And let me make a little more room here. Get rid of this plus sign for the time being. And then my, something, I need more room. And then what's my R triple prime? Isopropyl. The carbon with the Grignard is the carbon this bond will be to. The carbon with the Grignard, in this case, the middle one, and you have not one, but two. And I'll put in my hydrogens left. So that's this. This one, what's our prime? Methyl. And now 2 days later, I'll be finished putting in the hydrogens. And notice from two simple molecules, methyl acetate was common name, or methyl ethanoate, plus this isopropyl magnesium chloride, which is easy to make. I'm making this very, very complex alcohol. And the methanol, the second one, is short chain, so I can easily distill that off to get my first alcohol pure. And that's the fun part of a Grignard. Now, my gift to you is, for this reaction, ester plus 2 molecules or moles of a Grignard, second step acid and water, I will never give a synthesis problem. This is not polite. I think the Supreme Court still has outlawed cruel and unusual punishment to students. I think you never know what the one we have. Oops. Keep politics out of organic chemistry. All right, let's talk about one of my favorite areas, because I worked in this industry, and just to show off, I think I have about 9 US patents in amines and their derivatives. So I know a little about this. That's an understatement. Anyways, amines. That's where you take ammonia, NH3, and replace the hydrogens on NH3 with alkyl groups. You have a primary, secondary, tertiary amine. How do you name it? Well, most people working amines don't use IUPAC, use the common name, name each R group as the alkyl group in front, and add the word amine at the end. Now, there's one special amine you should know, and this is like benzoic acid and also like phenol. IUPAC said this name's been around for generations. We're not going to change those organic chemists. So when you have benzene ring with NH2, that's called aniline. Now, these are amines. And in amine, nitrogen has 3 bonds to it, unlike carbon. Now, there's certain amine products or derivatives. Derivative means made from amines which can have 4 bonds. Carbon always has 4 bonds, but nitrogen can have 3 or 4. Depends on what you're making. And let's go to something near and dear to my heart, a quaternary ammonium salt. Notice you have a nitrogen with 4 groups on it, R prime, R double prime, R triple prime. They can be the same or different. And you have a positive charge on the nitrogen. All molecules in nature have a net zero charge. So that's why we need an anion. For this class, I'll just stick to the halogen anions, X minus. How do you name that? Well, you name the R groups as the alkyl groups in front, then add the words ammonium halide. And if it's Br, the halide is bromide. If it's Cl, the halide is chloride. If it's iodine, it's iodide. Now, amine salts, I made a mistake here. And amine salts are where you have 1, 2, or 3 R groups and 1 hydrogen on nitrogen. Note R prime and R double prime can be hydrogen. And you name that the same way as a quaternary ammonium salt, except you won't have 4 different alkyl groups like you, or 4 alkyl groups like you would in ammonium, quaternary ammonium salt. Now, I don't have down here, but I better remind you, because this is real near and dear to my heart, where do you find products that contain quaternary ammonium salts? Fabric softeners, and that's an area I worked in. I have some patents in that. I worked with Procter & Gamble when I was out at a company that supplied them their quaternary ammonium salts for Downy. I also worked with Lever Brother one day for theirs, which is Snuggle. And if you watch the video, you can hear about the Snuggle Bear, how it came about to be a mascot. And the other thing, if you watched my video, you learned about the mouthwash I use to keep my gums from going bad, and that contains a quaternary ammonium salt. Now, how do you make an amine? You take an alkyl halide, Rx, and that's where X can be chlorine, bromine, or iodine, reacted with ammonia in the presence of base. I could put down bases, but I'll just use the word base, and you get a primary amine. The nitrogen bonds to the carbon with the halogen. The nitrogen bonds to the carbon with the halogen. Now, if you take a secondary amine and react it with an alkyl halide, same or different, primary amine, you'll get a secondary amine. And the R prime, the nitrogen bonds to the carbon with the halogen R prime. Do you break carbon-carbon single bond? No. And next, if you take a secondary amine and react it with an alkyl halide, again, the 2 R groups here will still be on the nitrogen, and this R double prime will now be on it. And the carbon with the halogen on the R double prime will be bonded to the carbon, and with the nitrogen, your tertiary amine. Now, a special way of making primary amines is reacting a nitrile, which I'll never ask you to remember the name, but it's a carbon-nitrogen triple bond, which you know, pi bonds can be broken. This has 2 pi bonds and 1 sigma bond. I won't ask that on a test, but if you add excess hydrogen to catalyst can be nickel, platinum, or palladium. You break the 2 pi bonds, and each carbon, or each atom of the triple bond gets 2 hydrogens. And you can write it this way or this way, and that's a great way of making primary amines. And I worked for a company that did this to the tune of about 3 million pounds a week, sometimes more. Now, something very near and dear to my heart is this reaction, which I'm a world authority on, and that's if you take a tertiary amine are reacted with an alkyl halide and base, you'll make a quaternary ammonium salt. And those are things like responsible for your fabric softener or certain antibacterial products like in mouthwash. Also things, they use quaternary ammonium salts to disinfect hospital operating rooms. And let's take a look at this. Let's have some fun. And if we take these two molecules, the question is, in the presence of base, what do you get? Well, you have to look at what you have. And first thing is you look for what's different, what's not carbon, what's not nitrogen, should get your attention like that. Ooh, a nitrogen, what's what I say, what's not carbon, what's not hydrogen? I have a nitrogen. Notice I have two methyl groups. That's what this means in a bracket. You don't see that often in carbon, but it means we write it that way. And this ethyl group. So this is a tertiary amine, where this I can call R and R prime, and my ethyl group R double prime. Excuse me. And here, what's different? Carbon, carbon, carbon. Ooh, chlorine. This is an alkyl halide, where X can be chlorine, bromine, or iodine. In the presence of base, I'm going to make a quaternary ammonium salt, something that's near and dear to my heart, that got me around the world, places like Amsterdam, London, Manchester, Guadalajara, Toronto, or all around the world. So what do? What's attached to the nitrogen stays attached. Which carbon has the halogen, the N carbon? Do you break carbon-carbon single bonds? Like I said, this is my R triple prime. This is my X. And the answer is no, so I have 3 carbons. You have a plus charge in the nitrogen. You don't have to write the charges. Don't forget the anion, and that's chlorine minus. And that's how you make that quaternary ammonium salt. And I've been a good boy because then if you're in the industry, we call them quats. And I stayed away from slang in this class. Thank you, Dr. White. You're welcome. All right, now amines are acids. Amines are bases. And if you react it with an acid, you get a proton transfer. So if you take an amine, primary, secondary, tertiary, remember R prime and R double prime can be H, you'll form this amine salt. And this is an important reaction because that's how we make certain chemicals called medicine, water soluble in your stomach and your blood. All right, now, next, I talked about a derivative of an amine. Derivative means something you make from an amine. That's called an amide, which I've worked in too. Company made amides. And an amide is where you have a carbonyl with an R group, nitrogen on the carbonyl, And on the nitrogen, you have R prime and R double prime. Now note, R prime and R double prime can be hydrogen, or they can be alkyl groups or any combination. I forgot to mention, in amine salts and quaternary ammonium salts, notice there's 4 bonds, covalent bonds to nitrogen, where in amines and amides, there's only 3. And that's something you'll have to remember. All right, how do you make an amide? You start with a carboxylic acid and react it with either ammonia or primary, secondary amine. Notice up here I say R prime and R double prime, one or both can be hydrogen. If both are, that's NH3, ammonia, or it's a primary, secondary amine. And you get this amide. You lose water from there, the nitrogen bonds to the carbonyl carbon. And the question is, what's your, here, no, I'm ahead of myself, carboxylic acid plus an amine, remember R prime and R double prime, one, both, or none can be a hydrogen, gives you an amide. And the question would be, give the organic product or products are the following, and I'll do this one. If we look at the first molecule, what do we see that's different? We got a benzene ring, but benzene will not react with an amine nitrogen compound under these conditions. So that's really an R group and a carbonyl OH, a carboxylic acid. And if we look here, ooh, we've got 2 R groups. Remember, 2 R groups on nitrogen. R prime and R double prime can be hydrogen. In this case, they're not. And you get an amide. So what's my R group? This benzene ring with a methyl group on it. What's my R prime and R double prime? This ethyl group. So I'll put my R group, because you don't break carbon-carbon single bonds. The methyl will be here. The R carbon with the carbonyl group bond to it is still the carbon with the carbonyl bonded to it, this one. Notice it's 1, 2, 3 separating. And then I'll have my nitrogen, and I can write it this way. Or this way, which most organic chemists being lazy like myself would, and either way would be correct on a test. Now, why did I pick this product? Because this goes under the acronym DEET, and diethyl tulamide, and that's the active ingredient in mosquito repellent. When you put on any commercial mosquito repellent on yourself, that's the molecule that keeps mosquitoes and other insects away from you. How does that do that? I have no idea. I know it does, and I told the story about that in my video. Now, if you take an amide and react it with acid and water, you'll break it down and you'll get back the carboxylic acid you would have used to make that amide. Remember, R prime and R double prime can be H or R's. Now, you'll get the amine, but in the presence of HCl, you'll get this amine salt. Why did I pick HCl? Because that's the acid in your stomach. And we'll learn later on this reaction of acid hydrolysis of an amide is how your body breaks down proteins to make amino acids. Coming attractions, it'll be very exciting. And because it's an amine you make in the presence of acid, you get the amine salt. I mentioned the video, but I'll mention it now. The fastest reaction in all Mother Nature chemistry is an acid-base reaction. It's called an eigenblick, and the blink of an eye actually faster. Or diffusion control. As soon as they touch, they react. There's nothing faster. Now, you can also have base hydrolysis of an amide. And here, if you take an amide and react it with sodium hydroxide, and that's the only base I'll use for this class, and water, you don't get back the carboxylic acid because in the presence of acid, the carboxylic acid proton, you make the carboxylate anion. So you get the carboxylate anion of the carboxylic acid you would have used to make that amide, and you get the amine you would have used to make that. And again, R prime and R double prime can be hydrogen. So in both of these reactions, it's important to remember that when you get certain functional groups, they can react with the reagent you started with. Like here, the amine that you get from this acid hydrolysis reacts with the HCl to make the amine salt. The carboxylic acid you get here initially immediately makes the carboxylate anion with sodium hydroxide and water. Now, next I talked about heterocyclic compounds, which are quite exciting area. Things like folic acid and many other important compounds we use in our body in our daily life are heterocyclic compounds. But the thing I ask you to remember is one, you should know what is a heterocyclic compound, how to define it. That's a ring with carbon atoms and other atoms, such as oxygen or nitrogen. And then there's only one heterocyclic compound I want you to remember, and that's pyridine. And a derivative of that that's made into a quaternary ammonium salt is in the quaternary ammonium salt in the mouthwash I use, like Scope, or I buy the Walmart equivalent at more than half the price, like a lot more. It's the same thing. All right. Wow. And with that, I'm done for tonight. Don't forget, tomorrow I'll be sending out the password. You'll have till Friday. So that means if you want to, you can study this tomorrow and work on the test tree on Friday. And that gives you plenty of time. Now, I'm going to ask a question of all of you, and send me an email, or after class today, let me know. Next week, I was thinking, because of my schedule, I have some personal stuff going on. I was thinking of doing the review either Tuesday or Thursday morning. Is that a problem for any of you, or I could do it, shift it Tuesday, Monday night late? Let me know, would you rather have it Tuesday morning or Monday night late? Late would be about 8:30. It's going to be a long night for Dr. White, but I can handle it. So let me know by email which one's better for you for next week, because next week we're going to have test number 4. It's summer and these come quick. In the fall, it's 2 weeks apart between 3 and 4, because every 2 weeks is 1 week in the summer. That's why. But students do good. And good news, as of the end of the heterocyclic compounds, I will not go over any new general reactions. You've learned all the ones. I'll just show you how they apply in our daily life, which is the fun part. All right, with that, I'm going to say goodbye. I'll stick around if anybody wants any questions. I'll stick around for a little while. I'll say, gang gesund. Goodbye now. I stole that from Granny to Beverly Hillbillies. Bye now.